In this video, we're going to go over how to find the slope-intercept form equation of a line when given 2 points. Now, typically, I like to use point-slope form to do this kind of problem, and if you haven't studied point-slope form yet, check that out in the next couple of lessons, and you will see what I'm talking about. But for now, let's use slope-intercept form to do it. It's pretty sweet as a method, and some people teach it that way and don't teach point-slope form. So you're given the instructions, find the slope-intercept form of the equation of the line that passes through, and then we have 2 problems. So generally speaking, you have 2 points, 2, 9, and 6, 1. They're points on a graph. And we want to find the equation of the line that goes through those 2 points. Well, how do we do that? Well, first thing I'll start with is what I'm actually asked for. I'm asked for the slope-intercept form of the line, so let me start out with that as my template. That's going to tell me, just mentally, what it is that I need to go after, like what my goals are. Well, first things first, I need a slope and I need a y-intercept. Now, finding a slope is not so bad when given 2 points. We can do that with our slope equation, which we know is m equals y2 minus y1 all over x2 minus x1. So from here, I'm going to employ my skills with finding slope. So I'll do 1 minus 9, y2 minus y1, so 1 minus 9, divided by x2 minus x1, 6 minus 2. And if you're having trouble with slope, check out my videos on how to find slope and you'll be in good shape. So 1 minus 9 is negative 8 all over 4, just doing a little bit of simplification here. And now we have a slope of negative 2. So what? Well, we've got this template here. This is our end goal, and we found one key part of that template, m, the slope. So let's plug that in. We've got y equals negative 2x plus b. Okay, so we're in decent shape, but we still need that value of b. So what do we do to find the value of b? Well, there's one key idea in algebra that is, well, it's massively important, but it's simple. It's the idea that if you have points that go on a curve, in this case on a line, then we know those points also work in that line's equation. What I mean by that is when x is 2, y would be 9, or when x is 6, y is 1. So it's up to you what you want to plug in. I'm going to plug in the first point, but you could plug in the second. They're both on the line itself. You'll get the same answer for b as long as you solve it correctly. So 2, 9, I plug in 2 for x and 9 for y. And what does that do for us? Well, let's check it out. We are given an equation now with just one variable, b, which is what we want to solve for and eventually plug in for to give us y equals mx plus b. So I solve this out, I've got 9 equals negative 4 plus b, and if I add 4 to both sides, I will get 13. Negative 4 plus 4 is 0, 4 plus 9 is 13, and that's b. So we're not done. We need to now take these values and plug them into our equation. So we have the b value right there, and I'll kind of draw a little arrow. So we've got y equals negative 2x plus 13. And there is our slope-intercept form equation. So it's not about memorizing the steps and what to do. It's about starting out with the basic template of our end goal. Then we use the pieces in here to say, well, okay, how do I find slope? And build on what you already know how to do. We did that. Then it's using that idea of, well, I can put in an x value to get out a y value and solve for b. I'd encourage you to try both 6, 1 and 2, 9 to see that you'll get 13 no matter which way you do it. In that way, you'll show yourself that both points are on the line. All right, so that's it. That's how to do one of those problems. I've put a second problem right behind me that I'm now going to go over. It's got a little bit of a different feel to it, but it's very similar in scope of what we just went over. So if you're rocking on this, then you're in good shape. But I'd encourage you to check this one out. Okay, so same instructions. We want y equals mx plus b. That's our goal, right? So y equals mx plus b. Now from here, I need to find my slope, just like we did last time. Okay, so I'll do this over here. So m is equal to y2 minus y1. I'm going to go right into it. 5 minus a negative 4. Beautiful. All over x2 minus x1, 0 minus 3. Again, a reminder, if you're having trouble with finding slope or understanding it, watch my previous videos on rate of change in slope. You'll be in good shape. 5 minus negative 4 is 9. All over negative 3. and that divides out to be -3. 9 divided by -3 is -3. So now we have our slope. That's m, right? So we'll start plugging into our template. So we have y equals m, which is -3x plus b. Whereas in that last problem, we had to find our y-intercept by plugging in one of the 2 points. I'm going to show you that we actually already have our y-intercept. 3, -4 is not a y-intercept. It's not on the y-axis, but 0, 5 is, right? If your x value is 0, that means that you're on the y-axis and have a y value of 5, right? And if you see that, 0, 5 is right here. So we can actually just plug in for b right away if you want to be tricky with it. So y equals -3x plus 5. Sweet. And there's your answer. Now, just to show you that it would work if we plugged in the numbers, we could also have gone from this step down to here and said, well, y is 5 when x is 0, just like we did in the first problem. There's x being 0, and solve for b. -3 times 0 is 0, and you get 5 equals b, and sure enough, that is exactly what it is equal to. That's it, peeps. The type of problem that everyone's going to have to rock at some point in their math careers, solving for the slope-intercept form of the equation of a line that goes through 2 points.